So in the last lecture, we were discussing intermediate value property, and today also we are going to continue from the same. These lectures are for JEE attempt 2024, and one of the most important aspect of any competitive exam concerning mathematics, and especially calculus, or you can take a real analysis when it goes to a further level. They will always ask you at any level. They will always ask you something about intermediate value property for the continuous functions. And this is what we were discussing for the last couple of classes, right? So intermediate value property for continuous. Okay, just let me wait for people to join in, and then we shall start. Okay, so let us begin. So in the last class also we were discussing intermediate value property for continuous functions. Today also few of them we'll discuss, and then we'll go ahead and do other things as well. Okay, so now you have to see. I'm telling you one more thing. What is that? And this is another question. So question says, let f be defined from 0, 1 to r. Let f be defined from 0, 1 to r. Be continuous. Such that f0 is equal to f of 1. Such that f0 is equal to f of 1. Then we have to show that there exists x1, x2 belongs to 0, 1 such that fx1 is equal to fx2 and x1 minus x2 equal to 1/3. Okay, so how to do this particular thing? So what I'll do, as done in the previous question, I'll assume a function z defined from 0, 2/3 to r, f of x plus 1/3 minus f of x equals to g of x. Why I have done so? Yeah, in the last lecture I explained you that if I'm writing x1 minus x2 as 1/3, that implies that x1 would be simply x2 plus 1/3. Okay, but in other words, I'm asking from you that will there exist some x1 and x2 such that fx1 is equal to f of x2 is equal to f of x2 plus 1/3, isn't it? Yes or no?
Yes.
Okay, so it is equivalent to writing this only. Okay, so what I'll do, I have taken this particular function, that is g of x equivalent to g of x equivalent to this. Okay, now if you see why I've taken 2/3, because if I take 1 here, so it will become 1 plus 1/3, that is f of 4/3. And you can see that your f is defined from 0, 1 only. So I have taken the caution so that my function is well defined. Otherwise, see, if I take my function's domain, that is a g's domain from 0 to 1, then it will so happen that if I take 1 here, then it will become f of 4/3, which is indeed, you can see that the domain of f would not allow that. Okay. So what I have done, I have just written g defined from 0, 2/3 to r, such that g of x is equal to f of x plus 1/3 minus f of x. Okay. Now again, those trivial cases I'm writing here. Okay. So given that f of 0 equal to 0, so if g of 0 is equal to 0, what does it mean? It means f of 1 by 3 minus f of 0 would be equal to 0. And then there is nothing to prove, because now here in this case, you can clearly see that your x1 has become 1 by 3 and your x2 has become 0. So you can clearly see that instead of x1, I have written 1 by 3, or instead of x2, I have written 0, which implies x1 minus x2 is 1 by 3. This is one thing that you can clearly see. And here, instead of f of x1, I have written x2 plus 1 by 3, right? So instead of x, is that clear? So here there is nothing to prove, because x1 would be equal to 1 by 3, x2 equal to 0. It satisfies this statement, as well as this satisfies this also, because fx1 means what? It means f of x2 plus 1 by 3. So clearly f of x2 plus 1 by 3 is equal to f of x2 with given x2 equal to 0. So there is nothing to prove here. Is that clear? Also, if your uh, another portion was what? I think another portion was what I had to write. Another thing was to say if your other part, that is, let's say, uh, g of, let's say 1 by 3. Even try it. So what would be g of 1 by 3? G of 1 by 3, if it is equal to 0, then again there is nothing to prove. Okay, why there is nothing to prove? Because if g of 1 by 3 is equal to 0, then what does it mean? G of 1 by 3 is simply f of 2 by 3 minus f of 1 by 3 equal to 0. So if this is the case, then also there is nothing to prove, because here f of 2 by 3, you can write f of 1 by 3 plus 1 by 3. And here also you can write f of 1 by 3 is equal to 0. So clearly you can write that here x1 is what? Here x1 is also equal to, we'll have to see, right? x1 here x1 is 1 by 3. Okay. Sorry, x2 is 1 by 3, right? x2 is 1 by 3. But then your that will not be 0 now. तो वो दिक्कत हो जाएगी, राइट राइट रुक जाओ एक काम करते हैं, कुछ और सोचते हैं। ठीक है, तो एक ट्रिवियल केस लिया, एक और ट्रिवियल केस अभी देखते हैं। I'll see, don't worry. ठीक है, एक और ट्रिवियल केस, एक ट्रिवियल केस तो सामने दिख रहा है, g of 0 is equal to 0, then there is nothing to do. Is that clear? ये पता है क्यों लिखते हैं? बस इसलिए क्योंकि कोई तुमसे पूछ सकता है। सी देखो, जनरली जब भी इंटरमीडिएट वैल्यू प्रॉपर्टी करोगे ना, तो हमेशा इंटरमीडिएट वैल्यूज आती है। मतलब जैसे whenever I say that my यहाँ पे लिख रहा हूँ, let's say whenever I say that my function f of a and f of b assume opposite sign, तो मैं क्या कहता हूँ, there always exists x naught belongs to a comma b open. पर देखो तुम इन सारे क्वेश्चंस में जब भी पूछा जा रहा है ना, तो they are asking you does there exist x or x2 belongs to 0 comma, समझ पा रहे हो? So that is why I'm doing all these things, so that मतलब ये पहले ही मैं क्या कर रहा हूँ, what I'm trying to do, if g0 equal to 0, then there is nothing to prove. Why am I even doing the question then? Because see, if g0 equal to 0, if it comes, then obviously f of 1 by 3 minus f of 0 would become 0. That implies f of 0 plus 1 by 3 minus 0 would be 0. Or in other words, you take your x2 as 0. You simply take your x2 as 0. So your x1 would immediately what it will become. Because see, if x2 is 0, then your x1 will immediately becomes 1 by 3. See, from the question itself, because x1 is what? It is x2 plus 1 by 3. And also you can see if this is the combination, then x1 minus x2 will become 1 by 3. x1 minus x2. See, what you have to prove that fx1 is equal to fx2 and x1 minus x2 is 1 by 3, right? So isn't it that isn't that it satisfies the equation? ऐसे तो हो रहा है ना? It is satisfying the given equation, right? And so then there is nothing to prove. And similarly, the other case I was writing, I think I was right there also. So if the other case is like if g of 1 by 3 is equal to 0, then what does it mean? It means f of 2 by 3 minus f of 1 by 3 is equal to 0. Or in other words, I can say that f of 2 by 3 is equal to f of 1 by 3. Let's say this is x1. Let's say it is x2. Clearly, x1 minus x2 is equal to 1 by 3. And fx1 is equal to fx2, right?
Yes.
Then again, there is nothing to prove. Okay. Otherwise, another important case, let's say if f of 2 by 3, g of 2 by 3 is 0. What does it mean? It means f of 1 minus f of 2 by 3 is equal to 0. Or in other words, I can write that f of 1 is equal to f of 2 by 3 and condition that x1 minus x2 is equal to 1 by 3. Clearly, this is x1, this is x2. So if x1 is 1, x2 is 2 by 3. So clearly x1 minus x2 is 1 by 3. So whether these are all the, you can say, these are all such cases which are like sort of trivial cases, right? So that is why if these are there, so obviously there's nothing to prove. It still satisfies the your given statement quite obviously. Okay, so I'm not discussing about any of these. Okay, I'm not discussing these. I have taken in account of all these things. So I know that these may be one of the cases, right? Now let us start doing our question. And what was the question? The question was, so question was, now see, g of 0 is equal to what? It is equal to f of 1 by 3 minus f of 0, right? And note that it is given that f of 0 is equal to f of 1, right? It is given. It is given in the question itself, right? Is that clear to you?
Yes.
Okay, so it is given in the question itself that f of 0 is equal to f of 1. Now you see, if I find g of 1 by 3, and why tactically I did all these things, because I know these are the things that I'm going to use here. So f of 2 by 3 minus f of 1 by 3, right? And similarly, if I want to write g of 2 by 3, what it would be? It would be simply f of 1 minus f of 2 by 3, right?
Yes.
Okay, good enough. See, now, surprisingly, you'll find that if I add all these things, if I add all these things, so g of 0 plus g of 1 by 3 plus g of 2 by 3, what it would be? It would be equals to f1 minus of f0, right? And I know that f1 minus f0 are equal, so I'll write them as 0. Is that clear?
Yes.
Now, one of the question is that if all of them are positive, can it be possible that it is equal to 0? No. If all of them are negative, can it be possible that it is equal to 0? No. Right? So what I want to say is that at least one pair will have a, I should say, yeah, at least one pair will, at least what should I write? At least two of them will have, right? At least two pairs will have a, at least we get two pairs will have a negative sign.
Yes.
I'm saying two pairs. Why pairs? Because see, if this is positive, at least इन दोनों में से कोई एक ऐसा जरूर होना चाहिए जो negative. So at least, मतलब कैसे समझाऊं चीज? So I'll not write at least on all these things. मतलब मैं ऐसे समझा रहा हूँ, ये possibility दे. I'll write the possibilities. That would be good thing to see. See, if all of them are positive, then all positives added will never give you a 0. They will become a positive value, right?
Yes.
Okay. Then if all of them are negative, again there will be a problem. If one of them is positive, let's say this is positive, then g of 1 by 3 has to be negative, or like these are the possibilities. If this is positive, then this can be positive and this can be negative, and like likewise. Okay, so if this is negative, then this. Well, at least now you can see that at least in दोनों में ये pair दिख रहा है. This is bearing negative sign, opposite sign. Sorry.
Awesome.
Can you see that? And here also you can see that it is bearing opposite sign.
Awesome.
And if there are bearing opposite sign, then there exists at least one x naught belongs to what? Belongs to either 0 to 1 by 3, or you can write between 1 by 3 comma 2 by 3, or in other words I can write between 0 comma 1, such that g of x naught is 0, right, by intermediate value property. Is that clear,
Yes.
Harshit? Is there any doubt? देखो एक जगह एक पॉजिटिव से नेगेटिव साइन यहाँ चेंज हो रहा है, नेगेटिव से पॉजिटिव, तो एटलीस्ट 1 x नॉट के लिए तो कह ही सकता हूँ, मतलब यहाँ तो 2 बार हो रहा है, लेकिन ऐसा तो कह ही सकता हूँ, देयर एग्जिस्ट एटलीस्ट 1 x नॉट बिलोंग्स टू 0, 1 सच दैट g of x नॉट इज 0. और in other words I can write f of x naught plus 1 by 3 minus f of x naught is equal to 0. Or in other words I can write f of x naught plus 1 by 3 is equal to f of x naught. No issues about it. And it is satisfying your property. Let's say this is your x1. Let's say this is your x2. Now clearly x1 minus x2 is what? 1 by 3 aa bhi gaya. So it implies there always exists some x1 or comma x2 belongs to what? 0 comma 1 closed interval. Why closed interval? Because there was a case where your 0 was included, right? x2 is equal to 0, and here you can see x1 is equal to 1. So there were cases where they were included also. So there are cases where x1, x2 can belongs to closed interval 0, 1. So close में ये 0 और 1 वाले cases तो यहाँ से आ जाएंगे, और बीच वाले cases यहाँ से पकड़ में आ जाएंगे, such that f of x1 is equal to f of x2 and simultaneously x1 minus x2 equal to 1. The same thing you can generalize for 1 by n. अपन ने देखो अपन ने मतलब हमने कल परसों last time whenever our class was there we did it for 1 by 2, right? Now the same thing we can do for 1 by 3 as well, and in fact the same thing you can continue for 1 by n also. So for example, assuming n greater than 1, f defined from 0, 1 to r be such that f0 is equal to f of 1, show that there exists x1, x2 belongs to 0, 1 such that f of x1 is equal to f of x2 and x1 minus x2 is equal to 1 upon. So this for this also you can prove the same, because see on the same lines. So now you can define a function g defined from 0, n minus 1 upon n. Why I'm doing n minus 1 upon n? If you remember, for 1 by 3 I wrote g defined from 0, 2 by 3, right? Similarly, on the similar lines I'm doing this also, because see otherwise the domain of f will be violated. And now I'm defining a function f of x, which is g of x, which is f of x plus 1 by n minus f of x. Is that clear, Harshit?
Yes.
Why I have done this? Because I want to keep the domain of f intact. Otherwise, if I'm not going to write this, say, for example, if I would write 1 here, then it will be 1 plus 1 by n, which is greater than 1, which cannot be the case. So even if I place n minus 1 upon n, so if I place n minus 1 upon n, which is equal to 1 minus 1 upon n, so f1 is like it can be placed here, because see, you can clearly see that your function's domain is from 0 to 1, inclusive of both 0 as well as 1. Is that clear?
Yes.
Okay, good enough. Now what I want to convey is, I'm not going to write trivial cases right now, because I've done it quite many times. Now I'll write g of 0. What would be g of 0? It will be f of 1 by n minus 0. What would be g of 1 by n? G of 1 by n will be simply f of 2 by n minus f of 1 by n. Is that clear? And then you can
Yes.
see what would be g of 2 by n. G of 2 by n will be f of 3 by n minus f of 2 by n. And you can go all along and you can write things like these. And at the end, you will find that g of n minus 2 upon n will be simply f of, I think, 1 minus 1 upon n minus f of 1 minus 2 by n. And what would be g of n minus 1 upon n? It will be simply, I think, f of 1 minus f of 1 minus 1. Right? Is that clear? Harshit, is that clear?
Yes, sir.
Okay. Now add all these things. So if you add all these things, you can clearly see f1 by n gets cancelled here, f2 by n gets cancelled here. Similarly, f3 by n would get cancelled here. Similarly, you can see that in every cutting pattern, you can see in the former part, for the former part, there's a latter. So for f of 2 by n, there is a latter part. F of 3 by n, there is a latter part. So it would have cut by some former part. This particular term has got a latter part here. But for f1, there is no further part for which you can have a latter portion which cancels f1. Is that clear? So what I want to convey is that g0 plus g1 by n plus g2 by n dash 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 g of 1 minus 1 by n would be equals to what? Would be equals to 0. Is that clear? Because see,
Yes.
f1 minus f0, f1 minus f0. Now again the same argument that if all of them are positive, then it cannot be the case. All of them can be, all of them can never be positive. All of them can never be all negative. So there has to be one sign opposite. Is that clear? So there should be at least one sign which is opposite. Let's say all of them are positive. From here to here, all of them are positive, but it has to be negative in equal amount. Otherwise, how will this become zero? How will this become zero? Is that clear? So at least one of these g of 1 by n dash 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 g of minus 1 by n. No, at least what you can say, at least समझ पा रहे हो मतलब इनमें से at least one of them, I should not write contrary sign, but not all will have the same sign, right? Not all will have the same sign. So let's say one of the scenarios I'm discussing, let's say all these are positive. Let's say all these are positive. Then it has to be negative in equal amount, right? And if it is negative and all of these are positive, then there exists at least x naught belongs to 0, 1, such that g of x naught would be 0. And if I'm writing g of x naught equal to 0, that implies f of x naught plus 1 by n minus f of x naught is equal to 0. In other words, this is x1, this is x2. Or you can write that f of x1 is equal to f of x2 and x1 minus x2 is equal to 1 upon n. Is that clear? And all other cases, like if g of 0 is equal to 0, then there is nothing to prove. Here you will get f of 1 by n is equal to f of 0. And simply this is your x1 and this is your x2. So it will include 0 here. And last case, if you take if n minus 1 upon n is equal to 0, if this is equivalent to 0, then what will happen? Then clearly f of 1 minus f of 1 minus 1 by n would be equal to what? 0. If this is the case, then this is x1 and this is x2. So there, these x1 can be 1 also, x2 can be 0 also. But if x2 is equal to 0, then x1 has to be 1 by n. This case would be there. And if x1 is equal to 1, then this will be equals to 1 minus 1 by n. This is the case where gx2 is equal to g n minus 1 upon n is 0. So if I'm not saying that, if I'm saying that all of them are non-zero terms, then these two cases may not arise. But if I'm saying that, let's say this is 0 or probably any of these terms are 0, then all these cases would certainly arise. So here you can also write in more general case, then there exists at least x naught belongs to closed interval 0, 1 such that f of x1 is equal to f of x2 and x1 minus x2 is 1 pair. Is that clear? Harshit, is that clear?
Yes, sir. Yes, sir. Yes.
Okay, good. So all these things are, I think now is quite evident that you might have got all these things. So this is all about continuity. Now we shall start with a slightly different topic, which is called as differentiability. Not a different topic, but this is another. That is why I'm not starting physics right now. I just want to finish things, at least in mathematics, to a level where you'll start getting what I want to convey with physics also. Because okay, so let us discuss differentiability. Okay. So what I want to say, suppose I'm discussing differentiability, okay? Suppose f is a real value function defined on an open interval I. Defined on an open interval I. And let us say x naught is one of those points which belongs to I. Then f is said to be differentiable at x naught belongs to I if what? If limit x tends to x naught, f of x minus f of x naught divided by x minus x naught exists. And if this limit exists, then this is called as the derivative of function at x. Is that clear?
Yes.
And it is usually denoted by d by dx of function at x equal to x naught. Okay. The physical significance of this particular thing is that it signifies your instantaneous rate of change of the function, not the average rate of change. So what does it signify? It signifies the instantaneous rate of change of function. By which what I mean, I'll write that also. But let us first write two more things. What is something called as right-hand derivative and something called as left-hand derivative? What do I mean when I say right-hand derivative? So let x naught be an interior point of interval I, somewhere interior it is lying, then f is said to be having f is said to have a right hand derivative at x equal to x naught if limit x tends to x naught plus. What I mean by x naught plus, it means that I'll write it in the way that f of x minus f of x naught divided by x minus x naught exists, or in other words, limit h tends to 0, f of x naught plus h minus of f of x naught divided by h exists. And similarly, I can write what would be the left hand derivative. So left hand derivative of a function at an interior point x naught is said to occur at x equal to x naught. The same thing if limit x tends to x naught minus f of x minus f of x naught divided by x minus x naught if this particular limit exists, or in other words, I can write limit s tends to 0 f of x naught minus h minus f of x naught divided by minus h. I hope it is clear.
Yes.
Okay. And what do you mean by interior point here? What I'm writing. However, interior point is a topological term. You will learn all these things in your higher classes. But right now I'm just defining it quite, you can say vaguely, or you can say in an easier fashion. What is an interior point? Interior point is one. So if there is I is an open interval, if I is an open interval, okay, or simply so open interval, or you can say any sort of interval, let's say close also, then x naught it is interior means it can have all the points of I except the endpoints. Except the endpoints. Is that clear?
Yes, sir.
Okay. So these are the things that I wanted to tell you right now. Okay. Now another thing that one needs to see is I'll teach you these things, like I'll teach you the physical interpretation also, but right now we'll do some questions at first. Now some rules regarding some properties of differential functions. Some properties of differential functions. And what are those properties? Property number one, it says that suppose these are all algebra. Okay, so suppose f and g are differential functions and they are differentiable at point x equal to x naught, and let's say alpha belongs to R, then f plus minus g, in fact alpha x plus minus beta g, or you can say alpha into f, or you can say beta into g. In fact, you can also see that f into g, in fact f divided by g provided g of x naught is non-zero, are all differential functions. So if is that clear? This is what as the algebra of differential functions, are all differential functions. Is that clear?
Yes, sir.
Okay. Now another thing that I want to teach you is, okay, one very important thing is differentiability implies continuity. Differentiability implies continuity, not converse. What does it mean? If I say that suppose my function is differentiable at x naught, if I'm saying that my function f is differentiable at x naught, then it necessarily means that f is continuous at x. And why do I say that? See, let's say my function f is differentiable at point x equal to x naught. So what does it imply? It implies that limit x tends to x naught, f of x minus f of x naught divided by x minus x naught exist. Is that clear? If I'm saying that my function f is differentiable at x naught, what does it imply? It implies that limit x tends to x naught, f of x minus f of x naught divided by x minus x naught exists, and let's say it is equal to some constant f dash x. Is that clear?
Yes, sir.
And if I just take this x minus x naught there, so what I'll get? I'll get limit x tends to x naught, f of x minus f of x naught is equal to what? It is equal to x minus x naught into f dash x naught. Let's take limit x tends to x naught. So if I take x tends to x naught, this right hand side would go to 0, isn't it? So what I have found? I have found that limit x tends to x naught, f of x will simply be equals to what? F of x. So what does it imply? It implies the continuity is implying differentiability. So if the limit of the function is equal to f of x naught, that is the value of function at that point, isn't it equal to saying that function is continuous?
Yes,
So this is what we wanted to convey, and this is what we have got, right? Is that clear?
yes,
Okay. Now, another thing that I need to write here. We'll see the physical interpretation quite soon, but right now I'm more focused on teaching you differentiability. Okay. The third thing is, now if f is differentiable at x naught and g is differentiable at its image. What is its image? Differentiable at f of x naught. Then composition is also differentiable. Then I can say that g of f is differentiable at x naught. But the condition is that g must be differentiable at f of x naught, because see, if I'm defining the composition, now g must be defined at f of x naught. Like if I'm saying that f is defined and differentiable at x naught, then the domain of g will be g of f of x naught. So I'm saying that if g is differentiable at not x naught, I'm not writing x naught, I'm writing f of x naught. Okay, only then the composition g of f will be differentiable at x naught. Is that clear?
yes, sir.
And further, I'm writing it here itself. Further, if you see at number 0.4, suppose g of f is differentiable at x naught. G of f is differentiable at x naught, and g is differentiable at y naught, which is equal to what? Which is equal to f of x naught. And suppose that g dash y naught is non-zero. Suppose that g dash y naught is non-zero, and I'm all writing all these are necessary things. I'm not deriving it because the derivation you will learn in higher classes. And f is continuous at x equal to x naught, then g is differentiable at x naught and is equals to, then sorry, not g, then f is differentiable at x naught, and this f dash x naught you can write as simply g of f derivative x naught divided by g dash y naught. I'll explain you this thing, don't worry. Okay, so if I'm saying that my composition
Yes.
g of f is defined and g of f is differentiable at x naught, g is differentiable at y naught, and g dash y naught is non-zero, then f dash x naught is simply equals to this. F dash x naught is simply this. This is simply what you can say, simple. I'll do it for you. Now, see what I want to see. Let's say g of f is differentiable. What does it imply? It implies g dash f of x naught, and let's say I'm doing it at x equal to x naught into, by chain rule, इसका भी तो derivative करना पड़ेगा बेटा. So your f dash x naught will be equals to what? Your f dash x naught will be equals to what? G of f का derivative at x equal to x naught divided by g dash f of x naught. And what is f of x naught? It is equal to y naught. Okay.
Sir.
And similarly, there is something called as inverse function theorem, which I'm going to write it here. And these are very important thing for your exam. You'll find that direct application based questions are coming. Inverse function theorem, IFT. Suppose f is defined from an interval I to j is a bijective function. You know the bijective function? A function which is 1, 1 as well as on 2 is called as bijective function. If you remember. Do you remember, Harshit, or should I stress upon it?
No, sir. I remember.
You know this, right? And if these are 1, 1 and onto function, then your inverse is defined. If the function is bijective only, then your inverse is defined, right?
Yeah.
And let's say f is differentiable at x naught belongs to I, and f dash x naught is non-zero. Suppose f inverse is continuous at y naught, which is equal to what? F of x naught. Then f inverse is differentiable. And we'll see in the next lecture what is its derivative. And this is differential precisely at 5. I'll meet you in the next lecture.
Yes, sir.